Okay, class, this is the second part. Let's take a look. Let me make sure this thing works. Let's take a look at what we're doing here for, oh boy, wrong one. Let me move back. There we go. So this is part two. A buffer is made by using 0.3 moles of H. Now I'm going to simplify that to HAC, okay? And I have 0.3 moles of sodium acetate with enough water to make 1 liter solution. The pH of the buffer is 4.74. That comes in later on. This is as good as the pKa, which means we're going to be using the Henderson-Hasselbalch equation. Calculate the pH of the solution after adding 0.02 moles of NaOH. So here's how this looks. I have my acid. I'm going to add the OH. I'm going to get water, of course, as part of my products, and the other part of that is my sodium acetate. Okay, so this right here, obviously this one here is my acid, on the other side is sodium acetate. That means I'm starting with 0.3 moles, starting with 0.02 moles, doesn't make a difference, and starting with 0.3 moles. That's what we have so far from the information. If I add an acid to a base, whether it's a weak acid or not, doesn't matter. It still reacts to produce product. And what I'm left with then is 0.28 moles of the acid left over. In this case here, the base is completely gone. I'm left with 0. And over here, I'm adding this amount. Oops, there we go. I'm adding this amount to get that amount of moles of acetate because some of the acetic acid has moved over to acetate. Good. Once we know what the moles are, just by doing that, then we can start to plug into our Henderson-Hasselbalch equation. So right here I've done the stoichiometric part first by subtracting the moles I need and adding moles on the right-hand side.
At this time, any junior or senior 11th and 12th grade student who did not have their pictures taken in October, please report to the auditorium now. This is for 11th and 12th grade students who did not have their picture taken or would like their picture retaken. Please report to the auditorium now. Thank you.
Okay, so how we do this then is our base over acid for concentrations. Our pKa is going to be the 4.74 that we started with, because that's the basic pH of the buffer, which is also the pKa in this case. So I got my log of the concentration of the base. This is the base here divided by 1 liter gives us, of course, 0.32, and that's our concentration for the base. Because that's what the AC minus is. So that's going to be 0.32 on top divided by, and then the acid, of course, is over here, divided by 1.0 liters. Okay, so that gives us the same number as the concentration. I take these two here as a fraction, and whatever I get from the fraction, which is actually, the fraction is larger than 1, so this is going to be positive. This log ends up being something, I don't know, something very close to 0.06. I just did it on the calculator. I forget exactly what it is. So what we end up with then is something that looks very much like this. Now I want you to notice that before we added the base, we have 4.74 as the pH. After I added the base, I got 4.8. Okay, that's hardly a change at all, almost no change at all. So it's a very big resistance to change in pH. Now take a look at the next part here. This is very simple. It says for comparison. Now remember, we went from 4.74 to 4.80 as our change of pH. What would it be if I just had a concentration of this number of moles per 1 liter, right, of NaOH? Okay, so what would that be? Well, let's find the POH, because I think that's a little bit easier to find first. So this is the concentration of the OH. POH equals the negative log of the concentration of the OH. So that just means that I take the negative log, of course, of the 0.02 like this, negative log, let me grab my phone. Negative log of this is 0.02. Log is, and then I just change it. So I literally get 1.7 as my POH. So what does that mean? Well, we know that 14 minus POH equals pH, which means 14 minus 1.7 is 12.3 for my pH. pH equals 12.3. If I just had regular water, pure water and no buffer, look at the difference between Bonehead 12.3 versus 4.8. That's what a buffer does. That's the major difference between the two of them. All right, nice work, guys.